Okay, so we'll get underway. My name is Eddie Thompson. I am a solution engineer here at Sumo Logic, and today I shall be talking to you about Kubernetes and more broadly, our Kubernetes Explorer solution for Sumo Logic. Ably assisting me today, I have Ryan Johnson, who is our solution engineering manager here, and he will be answering questions live for us as we go. So I'll start off with a little bit of housekeeping. So basically, everything is going out live here. You can have questions asked, don't need to wait till the end. If you click on the Q&A button in your Zoom meeting, you can open that up and ask questions directly. Ryan will be answering those as we go, and if relevant, I will be answering some of those on live as well. If you wish to get a recording of this, we are recording the session and that will be available after. So you don't need to ask about that. It will be available. We'll be sending out the links to that. So don't bother asking questions about that because it will be available. And at the end, we will have some time for some Q&A as well. So I'm going to run through a few slides and then a live demonstration.
Yep.
So
just to re-emphasize what Eddie said, I'm here to answer any question you may have. Please post them in the Q&A. The interesting ones might pass over to Eddie as part of the live session. If this is going to be anything like our previous sessions, probably going to see a lot of questions come through, which is fantastic. I'll endeavour to answer those as best I can throughout the session. But all questions will be asked. We might defer them to after the session because I said we do get a lot of questions in these, but please do keep them coming in. And with that, I'll turn off my camera. Over to you, Eddie.
Thanks, Ryan. So I'll chuck my video off now and I'll kick off. So to start with, a little bit about who we are and what we do. So we are Sumo Logic. We are a machine data aggregation and analytics platform. We are the industry's first and only continuous intelligent platform. So what does that mean? We take in your logs, we take in your metrics, we take in your security events, and we allow you to provide some different lenses to this data, be it operational, security, business, or even global intelligence. So when we are also allowed to benchmark yourself against what's going out there in the rest of the market too. So to start with, I'm just going to baseline a little bit, depending on if you're completely new to Kubernetes, this might be really interesting. If you're an old hand and you've been working with it for years, bear with me. I don't want to tell you how to suck eggs, but we'll have a bit of an intro. So Kubernetes is a container orchestration platform. So it was developed by Google and they open sourced it, and it's now managed by the Cloud Native Computing Foundation, which is part of the Linux Foundation. Basically what it does is it does all the orchestration and deployment work for containerized applications, making sure that everything is to the state which you want. So desired state management is what it's called, and that basically means it is declarative. You tell it how you want it to be in the end, and it works out how that should actually be. You tell it how many replicas, it makes sure that they're defined across multiple hosts for redundancies, that sort of thing. You don't need to work out how it gets there, it does that for you. You just tell it what you want. The other thing that's really important to understand is everything in Kubernetes is ephemeral, which means nothing lasts. Everything in a container can come up, do what it needs to do, spin back down very quickly. And so we need to make sure that things are architected correctly for that. We need to have what needs to persist separate from the pods, things like that. But Kubernetes has its ability to scale elastically by this ephemeral nature. It doesn't need to worry about when things come and go, and that means it can spin up capacity very quickly and also reduce capacity very quickly, which means that we're minimizing our compute expenses to what we actually need to get things done. And the other important thing is it runs anywhere, so private, public cloud, or bare metal. And Sumo Logic can also run with that. Even though we're a cloud native solution, we can run with that anywhere that you like to deploy it, as long as it can connect to the internet. So the Cloud Native Computing Foundation, so non-profit part of the Linux Foundation. Sumo Logic's a silver member. We actually contribute directly to that with our Kubernetes solution. I'll go into that in a little bit more detail later on how we actually get the data in there. But key terminology, this is some important stuff to know about why our solution is different, how this actually functions. So some key terms: cluster. So this is the broad deployment of Kubernetes as a whole. So it contains a master node and a number of worker nodes. In practice, you only need one, but you would very rarely see an actual cluster which only had one worker node, as there would be no redundancy. So you have one or more master nodes and many worker nodes. You can have multiple clusters. Within those clusters, you have a node that is a worker machine that is basically just your compute. So be that a rack server in your data center, be that a EC2 instance on Amazon, a VM on VMware, it doesn't really matter. But that is your compute. That is where the pods live. That is where the work is done. Pods. Pods are the smallest object which you can deploy in Kubernetes that contains one or more containers. So even though the container is the smallest atomic object, you can't actually deploy a container. You must deploy a pod. So that's the running set of containers. The container itself, that is what you actually wrap up with Docker, the container runtime, or any other container runtime that you wish to use. And that is what actually contains the software and the application and anything else that is needed to run. Everything there is linked together. It makes it really easy to deploy it in different environments. If you've got a multi-cloud environment, you can use the same container, even though it's Azure or it's EC2 or it's VMware. You don't need to repackage it. It's really powerful to be able to accelerate that software development velocity. So now some things that are a little bit more specific to Kubernetes, but also really important to our solution in Sumo Logic. Deployment. So deployment is a specification for how you are going to deploy a set of pods, services to a cluster. And the important thing about this is, if you want to make a change, you make a change to the deployment, and then it replicates out to everything that is running. You don't need to go and make 10 changes individually. You just make the change once, and then Kubernetes deals with that under the covers. And it doesn't need to just be one type of pod that is in a deployment or one service. You can have a bunch of things that are linked together and have a deployment state. You deploy it, push that out, and everything gets deployed, and you can visualize it together. Now, namespaces, my slide here says it's an abstraction to support multiple virtual clusters on the same physical cluster. If you're familiar with namespaces in a programming language, it's the same thing. Basically, the important thing to realize is that names within a namespace cannot clash, but across namespaces, they can. So you can use this to have multiple versions of the same thing. And also it means that you can divide your cluster up logically between applications, between teams, and know that they're not going to leak in between each other and cause conflicts. Services. Services are really, really important. So it is the way that we expose the services, the network services, which are running on a set of pods to the world, to the wider network, to the internet, whatever you're actually using it for. So this is a key thing. So a lot of the time, people get a little bit down into the weeds of what actually goes on in Kubernetes, but the core thing it does is it exposes services to the world. That's what people think about when they say, okay, I've got a payment service, I've got a mapping service, I've got a web service. That's what they know that they're exposing on Kubernetes, and that's what people who are working with Kubernetes will get asked about. They might get asked about their namespace or their service, but more often than not, it's the service that people care about. So our Kubernetes app, it provides visibility into the worker nodes and their application logs, allows you to troubleshoot and monitor, and it also provides you with a bunch of really important security visibility that you don't get out of the box with Kubernetes. So, time for a demonstration. That's enough with the slides. We'll kick over and have a look at how it actually looks on the platform. So this is our Kubernetes Explorer. And you can see here, I'm in a namespace view at the moment. And one of the key things that we have with our Kubernetes Explorer is the ability to pivot between different views in this setup. So I've got deployment view, I've got a node view, a namespace view, and the service view. So I'm in the namespace view at the moment. I'm going to go over to the node view. So the node view, this is how we would typically deal with things in a traditional infrastructure-based tooling model. We're looking at the compute, the tin, what we're actually running the software on. And so we can see here, I've got 6 nodes. It's a bunch of compute running on Amazon. And I can click on one of these. It's going to tell me some useful information, what my CPU is doing, what my memory's like, how many inodes I've used, how many nodes I've got in this particular view. But it's very, very hardware metric specific. Below that, I can see which pods are running on the nodes. And you can see here that although they're in alphabetical order, unless I particularly know what's going on, there's not a lot to tell me where things might be. So if I'm looking for an issue with a specific service or a specific application, and I've got 10, 20 nodes, I might be spending quite a long time browsing through all these to find what I actually want to see, and no one wants to do that. So that's why we allow you to pivot through this data in different views. What becomes much, much easier is namespace view. So this provides a logical order to what we're actually viewing. I can see my cluster. I've got one cluster here, but I could have many, and they would be ordered in a logical manner. I can expand this. I can see at a glance which namespaces are running within this cluster. Now, over on the right, this is the dashboard view. Now, you can see here, cluster. So as I navigate through this, it's going to tell me what filters I've built out by clicking through. And that's also going to influence which dashboards that I can see at the moment. So at the moment, I've got a lot of different dashboards available to me because they're all relevant to the cluster level. I'm looking at my cluster overview right now, and it's telling me some stats for the entire cluster. Really good sort of like heads up check of what's going on. I can see some metrics for what my CPU, memory, etc. are doing. Below that, I can see at a glance which namespaces have errors in them. So I can see I've got errors in 2 of my namespaces, Sumo Logic and prod loggen. And I can also see which security rules have been triggered as well. And below that, really handy, just honeycomb views of my particular pods that are running in my namespaces. And I can see here, I've got a couple which have got some issues. And you can see here the difference between this one here, which is running fine. We can see that the status is just there at 1 and is steady. This one here, however, I can see that it is going up and down, which means that there is a problem with it. So I know that this one's got a problem, so I might want to actually drill into this a bit further. I can click on it and I get here a menu bar which gives me some other options. So it gives me things like related logs. I can drill into the logs which are related to this particular pod, maybe only the error logs, or even run our log reduce and get the error signatures. It's given me some options for some recommended dashboards, and also the related pod itself to drill down to, or the namespace. So I'm going to have a look at the namespace. I could navigate to this over on the left-hand side, but this is an easy way to do it. So you can see here, I've now had the namespace added to my filters at the top, and we've got a different dashboard, which is the namespace overview. So this is showing me how many pods I've got running, how many pods I've got failed, and the total pods. So errors by pod. I can see that I've got some errors, but they're all related to one particular pod, which is PagerDuty, and errors by container is the same, PagerDuty. But I can see here, I've got 2 pods in a failure state, but only 1 that has errors. So the thing that's sticking out to me is I've got a pod in a failure state with no errors. This carbon black one here. So if I want to have a look, a bit of an investigation in what's going on to this, I can click once again, drill down to the specific pod. This is where we start to get a little bit more into the weeds of what's actually going on at a deep level within Kubernetes. And this is where it is so important that we have metric visibility into what's going on in Kubernetes, because not everything is provided by the log messages here. So I can see here I've got 1 pod in a crash loop back off state. I'll explain that a little bit further in a moment. So basically pod restarts the last 15 minutes, thousands, that's lots. And pod events. So these are the events that are actually being queried by the Kubernetes API server, queried from, I should say. So this is not actually a log message that the pod itself is writing out. This is being queried. And the message is that back off restarting failed container. And that's the same message. Now, the working memory limit seems to be okay, and the CPU limit seems to be okay. Now, the pod state, this is really, really important and gives us a really great view of what's actually happening in a timeline model. So this is tracking a few different metrics, but we can see here, this particular metric is pod container status waiting reason. And the reason is crash loop back off. We can move along the timeline and we get kube pod container status ready. And then immediately after that, we get pod container status terminated. And the reason is OOM killed. And what is OOM? OOM is out of memory. So let's try and investigate a bit further and see what might be the cause of that. Okay. We can see here usage versus request limits. So basically, when a pod is started in Kubernetes, you can configure some limits. So you have a request limit, which is what it requests when it starts. And we also have another metric here, which is the resource limit, which is the most that it can request. And if it eclipses this request, and in this case it has, the scheduler from Kubernetes will kill it off. So what we've seen here is as the container working set bytes has gone greater than the limit, the scheduler has killed it off. And so there's like some guardrails that have been put in there for the cluster, but in this case it's too low. And we need to raise this limit to fix this particular pod. Now, the key thing to realize here is without this metric visibility, you would have a very difficult time being able to determine, as I just have in moments, what the actual cause of this issue is. You'd be sitting there at the command line going, kubectl, blah, 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 enter, 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 and trying to work out exactly what the likely cause is. So the metrics provide that visibility, the what of actually what's going on in Kubernetes. And it's a core part of what we actually are doing here. So that's sort of drilled into it a bit there. So what I'll do now is I'll pivot back to my slides for a moment and I'll talk a little bit about how we actually get this data in and what we can do with it and how some of the things that we do are a little bit different. So here we go. Key things to realize here is our collection strategy is different from the traditional collector base strategy for Sumo Logic in the past. And one of the key things we've done here is, as Kubernetes is a cloud native computing foundation governed project, we have gone with a completely cloud native computing foundation collection strategy. So all of these projects are open source projects that are governed by the cloud native computing foundation. So for collecting our logs from Kubernetes, we are using FluentBit. Now, FluentBit is came out of the FluentD project, and it is a lightweight, low memory version of Fluent, which is written in C rather than Ruby. So it's an executable that's completely compiled. You don't need to package any libraries with it. There's no gems that it needs. Makes it very portable, very lightweight to run. It doesn't have all the capabilities of FluentD. It's a very lightweight log router, basically. It picks up the logs, ships them off. In this case, it ships them off to our enrichment pipeline. Events. Events are polled from the Kubernetes APIs themselves. We use a FluentD plugin, which we wrote for this purpose. So FluentD runs it as a pod, and also I'll say that FluentBit in this instance runs as a daemon set. That is, it is deployed to every host in the cluster. It doesn't run as a sidecar. Metrics. For metrics, we are using Prometheus. Everyone loves Prometheus. It's very, very powerful. It has great auto discovery capabilities. It's really easy to get in there and instrument everything and scrape those metrics. Traditionally, where Prometheus has fallen down is that it is difficult to scale, and you tend to end up with a lot of silos of instances of Prometheus. It becomes hard to aggregate that data and look across everything. Security. Now, security is one of those things that when Google open sourced Kubernetes, there wasn't a lot of options that came with it. There were audit logs, but not great ways to see what was going on. So Falco is an open source kernel level anomaly detection tool. What that actually allows you to do is see at a deep level what's going on at sort of an IDS type thing has a bunch of rules that you get out of the box, but it can also modify and add to yourself. And things that trigger those rules can pop alerts and gives you a level of security visibility within the Sumo Logic platform. You don't have to deploy Falco. If you don't have any security tooling running at all, it's a lot better than nothing. But if you're using security tooling for from another vendor that you're happy with, that's absolutely fine. You don't have to use Falco to make our solution work. So I'll come along to the enrichment side, and this is where the magic happens. This is the secret sauce. So every single log event, metric or security event that is generated flows through our enrichment pipeline. So normally, when you've used a lot of tooling, you'd be able to see with a particular log message something like the node, possibly, or the pod or the container that it came from. But that doesn't give you a lot of sort of information about what's actually contained within, what matters. And that's why we also tag things with service, deployment, and namespace, because that is what allowed me before to pivot between these different views of the data within the Kubernetes Explorer. And then all of this collection is deployed via a Helm chart, which means that you can literally deploy it with one line to the cluster. Everything gets pulled down and deployed automatically. And we actually have a Terraform provider which sets up the Sumo Logic side of it as well. So it's actually very, very tidy to deploy, and you can deploy it on all of the various cloud providers. So AWS, Azure, GCP. We support all of their actual hosted models, so AKS, EKS, GKE, and also your own deployed models. It doesn't really matter to us. And the other thing too is it all has a consistent view for us. So this is where we get to what we're sort of talking about, discoverability. Everything that you saw before, the difference between that infrastructure-centric viewpoint, where I expanded the nodes and all the pods were just scattered around because they need to be that way for redundancy. It's complex, it's slow, it's really hard to find what you're looking for. And the big thing here is it's disconnected from the customer reality, because as I mentioned before, what's exposed to the world? Services. Your customers don't care that you're running Kubernetes. They care about the services that you are exposing to them. And even some of your developers may not care that you're using Kubernetes. They care that their service is functional, and that's what they're exposing to the world. So being able to have someone come to you and say, I've got a problem with the payment service, or I've got a problem with the map service, and you can pivot to your service view and see that directly, is hugely powerful. It's simple to understand, it's quick to find the issues, and it is tightly connected to the customer reality. So this is something I'll jump back into and I'll show you a little bit more, but we've actually got a really strong unified DevOps and SecOps ecosystem that we've been developing out. So it's not just the things that we've built, we've also got things that are being built by some of our partners as well. So across the CI/CD side, we've got things like Circle CI, CodeFresh, Armory, Harness, all vendors who are doing great things, who you can pull in their information as well and see that consistently within the Sumo Logic environment. As I mentioned before, we're compatible and able to pull in information from all the major cloud providers. So whether you're running it yourself on Amazon, Google, or Azure, it's all consistent. Everything is available for you there. And the SecOps side, as I mentioned, Falco, we bundle that in there, but also if you're using things like vulnerability scanning or code analysis, container analysis management, so Twistlocks, Stacklocks, Aqua, Tigera, JFrog X-Ray, they're all available in there and they're all within the Explore platform. So I'll just jump back over here for a moment. And I'll go back up to my namespace view. So I'll jump back up here to my namespace for the loggen, because I remember before we had a look at Carbon Black, and there was another one, which was PagerDuty. And we could see that PagerDuty had some issues as well. So let's have a look at this particular pod here and see if it's sort of similar to the issues that we had before. So once again, we can see the pod is in a crash loop back off state. It's restarting over and over again. And the event is that it's back off restarting failed container. So we're looking pretty similar. But what's going on here? Okay, so we've got some different things going on. We can see that the container started here. Container status ready. Reason waiting is crash loop back off. But, okay, this is different. Pod container status terminated. And the reason here is error. Okay, so we scroll down here and yeah, so it's not the same issue that we see before. We're definitely not eclipsing any limits. It's not getting killed off by the scheduler. It's getting killed off due to an error. So let's pop back a bit further. Yeah, so we see here that this was the pod that was showing errors. So what I might do is, let's have a look at the logs. So I click there, and if you're familiar with Sumo Logic, this is probably a view that you've seen before, but you can see here that it's just really easy to pivot across to this, and it's all auto-filled in everything that I need. So the namespace, the cluster, the deployment, and the pod. So all that's there. So let's just have a bit of a scroll through and see if I can see anything that's relevant here. Okay, that jumps out to me. So I'm getting a 401, which is an authentication error. Let's see if anything else is of interest. Okay, collect name. Access ID. So let's just grab this one here. And I'm just going to have a look across everything for this access ID. And so let's have a look in the last hour, what's been going on. Okay, I don't want to look at all these, so I'm going to use log reduce. So log reduce is our pattern matching algorithm. It's going to iterate through all those results. It doesn't sample, and it's going to have a look at the structure and value and break them down into what we call signatures. So I can see here, there was a bunch of that stuff where it was all the same, and it just said final value for what was given. But this is interesting. It looks like someone has deleted the access key. So I can actually expand on this as well and show me the related logs to this. So, okay, it looks like someone from the SOC has disabled an access key and then deleted the access key. And that is likely what is causing these 401 authentication errors. So it looks like we've offboarded a user and haven't checked if their API keys are in use where they actually were. So that is another example. So the important thing here is that we've got everything together, and one of these errors I was able to solve what the problem was by using the metrics, and that sort of let me go from the smoke to fire. And the other side of this one is I needed to know the why. And I was able to find that deeper context by being able to drill down directly into the logs and find that information quickly. And that's the real power of what we've built here in the Kubernetes Explorer, is bringing all this information together allowing you to pivot through the different views and go deep either into the metrics or into the logs, depending on what you need to find out. We think it's really powerful. I think it's something that people find really useful. We've done a lot of work with our customers on this, what their specific use cases are, how they need to see things. So I talked about some of the partner apps before, so I'll just show you a little bit more about that. So because here, as I mentioned before, we can pivot through different dashboards. Say I've gone into my app catalog here, and I can click on Kubernetes. We can see all the things which are related here. So things like StackRox, Twistlock, Istio for the service for the service mesh. But say I've got some particular application. I can do things like I know I've got these installed, so I can go down to Twistlock. I can see my overview. So I can see, based on the same navigation view, I can see what's going on with my Twistlock information as well. So how many vulnerable hosts have I got? How many CVEs have fixes available? What compliance violations I've got? And this is all presented to me in that same view that I can pivot through, and it's consistent. If I wanted to have a look at what's going on in EKS and I've got some problems with my API server, I'm actually pulling in that data from CloudWatch as well, and I can see what's going on. So not just within my own side of the environment, what's actually going on the EKS side as well. Have I got some scaling problems? Do I need to log a ticket? Do I need to increase some resources? But this is all information which is available and easy to pivot to. So one of the other things I'll show you briefly is this has been built in our new dashboard framework. So one of the things I can do here is add a new dashboard panel. So this is a little bit different to the previous way in Sumo Logic, where you'd sort of create a query and then add a panel to the dashboard. This way you can actually create a dashboard, and I can do things like add a panel. And I want to add, say, a time series panel. Now this is a little bit different from what things were before, but I really, really like it. So we can now use custom metadata. In this case, I'm going to look for a cluster, and it's going to show me things which are related. So auto-completes. Now say I wanted to have a look at, these are all the metrics that relate. Now say I wanted to look at a container memory metric. Previously, I needed to know what the metric value was, but now we've got substring search. It's only a little thing, but it's really handy. So now I can just type mem, and it's going to show me all of the related metrics. So I can go, that's what I wanted, container memory usage bytes. And I can choose an aggregation. I can say no aggregation if I want, or I could say, show me what the max was. And if I wanted to break this out, I can say, break it out for me by container. So now I get my matching time series. I can go over to the chart and I can see the various things that are there. And say, I don't want a line chart, I want an area chart for this one. And I can change the color palette if I want. I'm going to add that one to my dashboard. Now, maybe I want to add another panel as well. And this time I'm going to say, I'm going to look for, once again, cluster equals my Trouble Logic cluster there. This time I'm going to look for a CPU metric. So CPU, show me the related metrics that say CPU. and I want my container CPU usage. And I'm going to say aggregation for this on my average. And I'm once again going to break this out by container. So here's my matches. Go back to my chart. And this one, I don't want a line chart, I want a column chart. So add this one to the dashboard. I've got my 2 here. And I can save. So it's going to ask me what I want to call the dashboard. So it is awesome dashboard. Save that in my personal folder. So we can see here now it's saying all saves, all changes have been saved. Now, that's really handy. It's a nice little, give me some metrics. What I'm going to do though is create a stack linking. Now, what's a stack linking, you may ask? This allows us to relate the dashboard to the Explore view. So I can choose a field as a key. So in this case, I'm going to use cluster as my key and my value as so now I've added this stack linking key. I can go back to an Explore window, and anything that matches this particular key cluster and that particular value, now I can see, oh, what's showing up within my list? Eddie's awesome dashboard. And what's really handy about this is it means that you can create dashboards for your users which are relevant to their particular application or their particular business unit. Anything that you can create a metadata field for and that is associated with their logs or their metrics, they will see that dashboard come up automatically for them within context. Hugely powerful. Now I put in a specific key and value, but you can put in wildcards as well. So it means that you can have dashboards which are more broadly applicable, wildcard them, have them show up contextually, and it doesn't just need to be at the cluster level. It can be at for a deployment namespace, whatever value you like, it's going to show within that pivot. Very, very powerful stuff. So that's sort of like the key things that I wanted to sort of take everyone through today. So what I'll sort of leave you with is, please try it out. So Sumo Logic is a SaaS platform. You can jump onto our website at sumologic.com/sign up and run up a free trial. There is no obligation there, and you can be up and running in minutes. Sumo allows you, as I mentioned, you can install our Kubernetes solution via a Helm chart. It's a one-liner. Throw it on one of your development clusters, a test cluster, and have a look at it. See what it actually looks like with your own data. And if you wish to continue the conversation, please join us at the Sumo Logic Dojo, which is our public Slack channel we have available. Go to slack.sumologic.com. You can grab a magic link and jump into our public channel there, and you can talk to lots of the Sumo Logic engineers, lots of other customers there, help each other out with queries and use cases and things. Really easy to get hold of people, and also just a great place to ask them all sort of how do I type questions that aren't really a sort of a support request type issue. But also I'll open up the floor for any Q&A. Please fire it off into the Q&A box if you would like to ask a question, as we've got a few minutes to go, and I will do my best to answer it. So I'll give it a couple of minutes here, and if we have no questions there, then I shall close it off. Okay, so a question from Martin here. So how do we discover apps in the cluster and identify what they are? So it's Prometheus that does the discovery for us. As far as identifying what the apps themselves are, normally, hopefully, in the service name, someone's used something that has some relationship to what the application is actually called, or the deployment set. There tend to be where you will find some useful information on what is actually what. Otherwise, you might have to drill down into the logs and have a bit of a look at what it's actually doing. So on the AI/ML side, particularly our log reduce algorithms, they are using machine learning clustering to join things together to see what's is going on. That's a really handy way to be able to have a look at things. And also we do have, let's double check within my Explore view here. So we've got things like our Kubernetes health check. So being able to see what's going on with the monitoring as well, monitoring the monitoring. So this is what's going on with Fluent D, this is what's going on with Fluent Bit, this is what's going on with Prometheus. That's with our sort of stuff, but you can also then see this in the Cluster Explorer. This is where we can see things like relative usage, where things are running hot, what things are actually going on that are issues. And forgot to mention this before, so I'll do it now. This is actually what's going on with Falco. So having a look at actually what's going on at the security side of things. So where are my critical alerts? Where are my errors? Which rules have been triggered? Which users are triggering rules? As I mentioned, these are all out of the box, but you can add your own rules into Falco as well.
There was a follow-up question on how many pods are needed for this solution. I believe, Eddie, correct me if I'm wrong, but I just think it's a minimum of one. You'll get that insight, but obviously Kubernetes being designed to be a distributed, like system, you're going to see more benefit from a greater deployment. Eddie, that sound good to you?
So yes and no.
Feel free to correct me.
You've fallen into the trap of relating pods to nodes. So for Sumo Logic, the pod count scales with the node count. So for things like Fluent Bit, as they are a daemon set, and you'll have as many Fluent Bit pods as you have nodes. For the Prometheus, you're going to have the pod count is going to scale with the volume of nodes as well, but you're probably going to have another 3 minimum for Prometheus, and for Fluent D, you're going to have likely another 3 for Fluent D. But yeah, so it's Fluent D in particular is a scaling one. So that the enrichment pipeline is running as a sidecar. So that particular deployment, you'll have not a linear growth, but if you've got 20 nodes, you're going to need more than the initial 3 that you might have for a 3-node cluster. For a minimum 3 pods per node at a small cluster, for a larger cluster, it would start to drop down.
Yeah. So the question there was, yeah. So the panelists here, we got a question. I don't think anyone else can see it. So the question was, is it a minimum of 3 pods per node? So any other questions from the group about Kubernetes, about Sumo Logic? Happy to address that in the time we have left.
Well, if we have no further questions, I would like to thank everybody for giving us their time today. I hope it was informative and enjoyable, and if not enjoyable, at least informative. But yeah, thanks very much for your time. Please do try us out. Feel free to reach out to us. And I'll give everyone 5 minutes back in their day. Ashley,
I'm sorry.
Sorry, Ashley just asked if, yes, we will have the recordings available. I think they're being uploaded to YouTube, and we can yeah, you'll be able to view that there. And yes, if you wish to get a hands-on, Ashley, please download a free trial, fire off your details there, and we will get in contact with you. Or if you like, you can just send me your email address, send you your email address directly to me in the chat, and I will get someone to contact you.
Thanks, everyone. Thanks, Eddie, for presenting today. Everyone, stay happy, stay healthy, stay sane, stay safe. We look forward to hopefully speak with you all soon, and please give it a try.